All right, here's some examples on related rates. A water tank has a shape of an inverted circular cone with a base radius of 2 meters and a height of 4 meters. If water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. The volume of the water of the circular cone is given by this formula. So the first thing we want to do with this is, I would say we should label this picture here. So I'm going to label this. I know that the radius of the entire cone is going to be 2 meters. And the radius of the little cone, this is the water being poured in here, is going to be, we're going to call that R. And the height is H. And the height of the entire thing is 4 meters. So what we're going to do here, we want to be able to find, well, let's see what we have here. We know that water is being pumped into the tank at a rate of 2 meters cubed per minute. We know meters cubed is going to be volume, so we know that dV dt is 2 meters cubed per minute. That's the rate of change of volume with respect to time. We're looking for, find the rate at which the water level is rising. So it seems like we are going to want to find dH dt, given at the time when h is 3 meters. So our goal here is going to be to change the volume formula into something that only has h's. We don't want two variables. It'd be easier if it's one variable. So we're going to do that. So we need to relate h and r somehow. Now, this is an example of a problem that uses similar figures. In this case, we're going to say r is to 2 as h is to 4. So this is just a similar figures. And we want this in terms of h, so I'm going to solve for r, and I'm going to say r is h over 2, just by multiplying the 2 over. I'm going to substitute in here, and I'm going to have volume equals 1/3 pi h over 2 squared times h. Simplifying this out a little bit, it's going to give me 1/12 pi h cubed. So now that I have it in terms of v and h, I'm going to take a derivative using implicit differentiation. So the derivative of v with respect to time is dv dt. Here we're just going to use a power rule. So I'm going to multiply 3, and that's going to give me 1/4 pi h squared. We can't forget dh dt. Now that I have this, I'm going to plug in what I know. I know dv dt is 2, so this is 2 equals 1/4 pi. H is going to be 3. We get that from here. And dH dt is what we're looking for. And now all we're going to do is multiply this out and divide it over. And we're going to get dH dt is 8/9 pi meters per minute. And it makes sense that this is positive because we're filling up the cone. Okay, so now let's look at the next one here. Excuse me. A coffee pot has a shape of a cylinder with a radius of 5 inches, as shown in the figure here on our right. Let h be the depth of the coffee measured in inches, where h is a function of time. The volume of the coffee is changing. So we already know the volume is changing. That's our rate of change. So dV dt, we'll just put this down right away, is negative 5 pi square root h. Show, this is a little bit of a proof, that dH dt is negative root h over 5. So I know that the volume is pi r squared h, and I get that from this formula here. I also know that r is not going to change. So even if this fills up, this cylinder here is still always going to have a radius of 5. So I'm going to plug that in right away. Volume equals 25 pi h. Now I'm going to take a derivative. So dv dt, again, implicitly with respect to time. 25 pi dh dt. And fill in what I know. I know that dv dt is negative 5 pi root h. So this is going to be equal to negative 5 pi root h. And we want to show that dh dt is equal to this here. So we're going to solve for dh dt by dividing 25 pi over. dh dt, if I divide 25 pi over, I'm going to get negative 5 pi root h over 25 pi. Pi's reduce, the 5 reduces, and I get negative root h over 5, which is what we wanted, QED. Okay, one last problem here. A baseball diamond has the shape of a square with sides 90 feet long. So we're looking at this baseball diamond. Each of these sides are 90 feet long. Tweety is just flying around the bases. So he's going around the bases like this. And he's running. This is second base here, and this is third base. He's running. Well, he's not really running. I guess he's flying. From second base here to third base here. And at some point in here, he's going to be this far away from home base. This is home base. He's running here at a speed of 28 feet per second. Notice here that this, if I'm going to let's call this distance x. This distance x is getting smaller. So the rate of change in time is negative 28 feet per second. So he's actually decreasing his spacing. Then let's label this z, because I think as we read, when Tweety is 30 feet from third base, at what rate is Tweety's distance from home plate? So that means from where he is to home plate, what is that distance? I'm going to call that z. So what relates the three sides of a right triangle? Pythagorean theorem. So we're going to have x squared plus 90 squared equals z squared. And we're looking at this right triangle here. So we're going to take a derivative, 2x dx dt, remember we're taking with respect to t, 2z dz dt. Now what do we know? We know dx dt is negative 28. We also know at this time when we're looking at it, we know that Tweety is 30 feet from third base, meaning that x is 30. So we're going to solve for z when x is 30. So we're going to go 30 squared plus 90 squared equals z squared. And z turns out to be 30 root 10 feet. And now we're going to plug things in. So we've got 2 times 30 times dx dt, which is negative 28, 2z, z is 30 root 10, dz dt. And we're going to divide this over here. And notice that those simplify, so we're going to get negative 28 over root 10 equals dz dt. If we wanted to find out what that is, that's actually an approximation. That's approximately negative 8.85 feet per second. That seems about right. I mean, if he's going 28, negative 8, this is going to change a little slower than that is. And those were all that I need to do. So we had 3 problems. Hopefully this helps, and if you want, you can take a look at all 3, rewind, whatever you need to do, and then that's it.